This video is on linear functions in slope-intercept form. This example, we will be writing the equation of the line in slope-intercept form given the slope and the y-intercept. We will also graph the line. Slope-intercept form, if we recall, is y equals mx plus b, where m is going to be the slope. It is the coefficient of the x, and the b is going to be the y value of the y-intercept. We will be replacing the m and the b. We will not be replacing the y and the x since we are given the slope and we're given the y-intercept. We will be able to find the m and the b. Then we can graph the equation. We can graph the function. So our first problem says m is equal to -1/2 and the y-intercept is 0, 3. So m is our slope. That means that the m is the -1/2. And then the y-intercept of 0, 3. The b value is the y value of the y-intercept. So the y-intercept is x is 0 and the y is 3. So that will be our b value. Our equation will be written as y equals mx. So our m is -1/2. Then we have our x. Then we have our b value. So it's either plus or minus depending on what the y-intercept value is. So in this case, this is a +3, so we would put +3. This is slope-intercept form. And now we want to graph this. So to graph slope-intercept form, you actually start with your coordinate that you're given. You're given 0, 3, your y-intercept, and then from there, we utilize our slope. 0, 3 is our first coordinate. So I don't have any scales on this graph. I will make a note down here that I'm going to actually count by, which is CB1. That means that this graph I'm going to count by 1. So every space is 1, only a value of 1. So my y-intercept is 0, 3. So the x is 0, the y is 3. So 0, 1, 2, 3. Here's my y-intercept. Next, I utilize my slope to find new coordinates. As a reminder, slope is change in y divided by change in x. I'm going to make a little note to myself, and I will erase this. This is -1 divided by a +2, or because a negative divided by a positive, it gives me a negative. A positive divided by a negative also gives me a negative. So it could be a +1 divided by a -2. The reason I need to know that is because my slope is change in y divided by change in x. So my first change in y tells me that I need to go a change in y of -1. So if I'm here, my change in y of -1 would go down 1. But then it says my change in x is a +2. So I need to go towards the positives. So change in y of -1 is down 1. Change in x of +2 is right 2 spaces. 1, 2. This is where one coordinate would be. I'm going to do it again until I can't go any further. So change in y of -1, change of x of +2. Now, I'm going to try and go one more. So change in y of -1, change in x of +2. I'm a little bit off of the graph, and that's okay, because I know that that's about where it should be. Now, how can I go to the other direction? I don't want to do -1 over +2 again, because that would just keep going off the graph and I can't see the locations that it would hit. That's why I know that a negative divided by positive and a positive divided by negative are both negatives. So I could utilize the change in y of +1 and the change of x of -2 to continue going the other direction. So change in y going back to my y-intercept. Change in y of +1 means go up 1, and change in x of -2 means go left 2. So once I've moved that location, I put my point, and I can still see that this is in the direction of a line. I'm going to do that slope again of +1 over -2. So a change in y of 1, +1, change in x of -2. And this is roughly the most amount of points that I can make. So now that I have made all my points, I'm going to connect these because it is a function. I'm going to connect these the best I can. But because it is linear, I know that it goes on forever. I put arrows on the ends of the line. So this is the graph of y equals -1/2 x plus 3. I have a negative slope, which is shown by going down and to the right. And my y-intercept is at 0, 3. I'm going to erase that little information about negative divided by positive. Now I'm going to go over to question B. We are told that m is equal to 0, and the y-intercept is 0, 4. And again, the b value is the y of the y-intercept. So our equation would be y equals, I'm going to put this in, because this is 0, this looks a little different. I'm going to put y equals, m is 0, x, plus, and then it's going to be a positive 4, so plus 4. Well, the reason why this looks a little different is because the slope is 0. So how can I rewrite this? Well, 0 times x is just 0. That means that we don't actually have to have that 0x. The equation of this line in slope-intercept form is actually y equals 4. Because 0 times x is 0. And 0 plus 4 is just 4. That means that this is the actual equation in slope-intercept form. Now, is this equation y equals 0x plus 4 wrong? No, but it is not seen this way because 0 times x is 0. So what type of line is this? Well, if we have 0 slope, we have to remember 0 slope means it's a horizontal line. If the slope was undefined, which is completely different, it would be a vertical line. So we have to remember 0 slope means it will be a horizontal line, so it goes left and right. Again, this graph has no scale on here. I will say it is count by or CB1. So every space is 1. Still graphing in slope-intercept form, we graph the point first, which is our y-intercept of 0, 4. So 0, 1, 2, 3, 4. And our slope is 0, meaning my change in y is 0. But my change in x can be anything. A horizontal line, this is saying that any y value of any coordinate, the y value is 4. This coordinate, 1, 4, 2, 4, 3, 4, because all of the y values are 4. I can also do -1, 4, -2, 4. All of these have the y value of 4. That means that I can have all of these points and they form that horizontal line. So I can connect these and put arrows on the ends. And that is the graph of y equals 4, or y equals 0x plus 4. And again, this y equals 0x plus 4 is not wrong, but it is not written this way because 0 times x is in fact 0. As a reminder, 0 slope is a horizontal line. Undefined slope is a vertical line.